Hello and welcome to this video on global warming. This story is mostly about heat, so let's start with where that heat comes from. So the sun gives off electromagnetic radiation in the form of waves. We have long wavelength radiation like radio waves and microwaves, all the way down to short wavelength radiation like gamma rays. And these move through space at the speed of light all the way to Earth. When they hit the atmosphere, some of these types of radiation move easily through our atmosphere and some barely make it through at all. So for example, ozone, O3, in our atmosphere absorbs most of the ultraviolet from the sun, which is a good thing because ultraviolet causes sunburn, skin cancer and cataracts, among other things. So radiation from the sun hits the surface of the Earth and the Earth heats up and radiates this heat back out in the form of infrared. If the Earth had no atmosphere whatsoever, then all of that heat would be lost to space and the Earth would be a freezing ball of ice. But there are molecules in our atmosphere which trap this heat. And these are the greenhouse gases, and the main greenhouse gases are water, methane and carbon dioxide. And the thicker the layer of greenhouse gases, the more heat gets trapped in the atmosphere. This is how a glass in a greenhouse works. It lets the radiation through, but it keeps most of the infrared back inside. I'll give you another analogy. Putting more CO2 into the atmosphere is like adding more and more duvets or sheets to your bed. Your body heat gets trapped under those duvets and sheets and you heat up. The effect of all this extra heat is known as global warming. But that term is a little bit simplistic. Global warming is too simplistic a term. Global chaos might be a better term because the effects are chaotic. So for example, warmer oceans feed hurricanes and typhoons with more energy, which results in stronger winds forming. In the last decade, we've had some of the biggest record-breaking hurricanes and typhoons. More heat in the atmosphere means that more water can evaporate from the oceans, and that creates more clouds, so you get more rain, and so you get more floods. Heating the ocean causes them to expand. The oceans themselves expand. And add to this the meltwater from the Antarctic, and you'll find sea levels rising, causing further flooding. So you can see that global warming is a little bit simplistic. Now, a vector. A vector is an animal that carries a disease or parasite from one host to another. So for example, the bubonic plague, that was caused by bacteria that were carried by fleas, and mosquitoes carry malaria, dengue fever and lots of other nasty pathogens from person to person. So a vector is something that carries a disease from place to place. Now, normally humans don't tend to settle down in places where there are lots of mosquitoes. But if climate change happens, these insects will migrate into densely populated areas, and this could cause massive outbreaks of disease. Climate change will impact agriculture and food production around the world. In this projection, you can see that a 1 degree increase doesn't have a big effect on crop production, but a 2 degree or more increase would be catastrophic. Global warming would reduce the amount of space on the Earth where crops can be grown, and with a population of 7 billion, and quickly rising, this can only mean lots and lots of starving people. Now there are many other effects of global warming, but I haven't got time to go into them all here. It would certainly help if we humans stopped adding so much CO2 and methane into the atmosphere. So rather than burning fuels for electricity, maybe we should be funding green projects like renewable sources of energy. Given that growing trees absorb CO2 from the atmosphere, perhaps we should be planting more forests. So there we are, that's a quick run through of global warming caused by the greenhouse effect and a look at what might happen in the future if some of these projections are correct. Thank you very much for listening.